In our last few videos, we've been looking at the transformation rules. And we saw that if we were adding or subtracting outside of the function, we moved up and down C units in the Y direction. If we were adding or subtracting inside of the function, that was a change in X, and we were moving left and right C units, opposite of the sign. And in our very last video, we saw that if we have a negative outside the function, that would be a reflection in the Y direction, which would be over the X axis. And if we have a negative inside of the function, that's a reflection in the X direction, which would be over the Y axis. So what we've seen is that adding or subtracting gives us shifts up, down, left, or right. A negative gives us a reflection. What we're going to look at in this unit is what happens if we multiply our function by a number. And we're going to see that that's going to give us either a stretch or a shrink, depending on if C, our number we're multiplying by, is larger than 1 or smaller than 1. Let's look at how this happens. Let's say that we have a function, g of x, which is equal to 4 times the absolute value of x. We know from our basic functions that if y is equal to the absolute value of x, I'm going to graph that down here. We have 0, 0. The absolute value of 1 is 1. The absolute value of negative 1 is positive 1. And we know from our basic functions that it is a straight line out in this direction. And this is our y equals the absolute value of x. So we're going to see that g, our function g, looks similar in shape to this, but each one of our values of y is multiplied by 4. So if we take y equals 0, x equals 0, absolute value of 0 is 0, multiply that by 4, it's still 0. When x equals 1, the absolute value of 1 is 1. 1 times 4 is 4. If x equals negative 1, the absolute value of negative 1 is 1. But 1 times 4 is 4. So what happens is that every single one of these points on my graph, y equals absolute value of x, every one of those y values is multiplied by 4. And what happens is that we have our entire graph is stretched by a factor of 4. So this is a stretch by 4. And notice 4 is the number I'm multiplying by, so 4 is the number I'm stretching by. The 0, 0 stays where it is, and then the 1, 1 becomes 1, 4. And then this point, negative 1, 1, also becomes 4. So the easiest way to graph these is to plot this point that would have been 1, 1 as 1, 4, and then draw your graph. Let's see what happens if we have a number less than 1. For instance, let's say we have h of x equals 1/3 x squared. So what I'd like you to do is list the basic function and then graph the basic function. And be sure to plot when x is -1, when x is 0, and when x is 1, because we're going to need those when we do our stretch or shrink. So go ahead and pause the video, write the basic function, sketch the basic function, and then rejoin me. And I see here my basic function is y equals x squared, because that's the graph we're looking at. And when I graph that, I have 0, 0, 1, 1, -1, 1, and it's the parabola, the nice curved shape. All right, now, when we look back at our function here, h of x, we see that we are multiplying by 1/3. Because we are multiplying, that means it is a stretch or a shrink in the vertical direction, up and down. And because 1/3 is smaller than 1, that means each of my ordered pairs is going to shrink. 0 times 1/3 is still 0. 1 times 1/3 is 1/3. -1 times 1/3, excuse me, this is 1 again here. 1 times 1/3 is 1/3. So what we have is a flattened down, shrunk parabola. Sometimes it's hard to graph 1/3. We're just kind of eyeballing 1/3 here. And on a coordinate system on MyMathLab, they want you to graph integers. So what we're going to see is that a shrink in the vertical direction, up and down, by 1/3, actually spreads the graph out in the horizontal direction by 3. So we're going over 1 and up 1/3. That's the same thing as going over 3 and up 1. And we would do that here as well. And then my graph is that parabola. And notice that compressing it in this direction has the effect of stretching it in this direction. Let's look at an example that has several things going on at once. Let's say that we are going to graph the function g of x equals -5 x cubed plus 2. So I'm going to have you list the basic function that this should look like. I want you to graph that basic function. And be sure to plot when x is -1, x is 0, and x is 1. Plot those 3 points, because that's going to help us do our reflections and stretches and shrinks and whatever that we have. And then I want you to list your transformations. List your transformations. And I'm going to give you a hint here. You have 3 transformations. You have this negative outside the function, you have multiplying by 5, and you have adding 2. So you're going to have 3 different transformations, and you don't try to combine those. You just list each one separately. And I work from left to right. So do the negative, do the 5, and then do the +2. So write your basic function, graph your basic function, plotting those 3 points, and then list your 3 transformations. Stop your video, and when you're done with that, you can turn the video back on, and I will help you draw the picture. All right, so we see that our basic function is y equals x cubed, because that's what we have here. If I graph that basic function, I'm going to draw this fairly large to give myself plenty of room. And I draw my basic function, y equals x cubed. I know I have 0, 0. 1 cubed is 1. Negative 1 cubed is negative 1. And I know from memory that that's the one that curves upwards and downwards. So I have a graph that looks like that. Then I list my transformations. The negative, this first negative, is outside of the function. That is a reflection. Changing my y so that is over the x-axis. Then I have the 5. That is multiplying by x cubed. 5 is more than 1. And be careful here. The negative is a reflection. That's separate from the stretch or shrink. So we're only looking at just the number 5, not negative 5. So 5 is more than 1, so that is a stretch by 5, factor of 5. And then finally my +2, that is outside the function, so that is up 2. So those are my 3 transformations. I'm going to do my reflection first. So that tells me that I'm going to reflect over the x-axis. So the x-axis, this axis, my mirror. So 0, 0 stays where it is. 1, 1 becomes 1, negative 1. And negative 1, negative 1 becomes negative 1, positive 1. And I'm going to draw this as a dashed line because this is not my finished answer. This is just the reflection. And it's much easier to do reflections at the axis. So go ahead at the origin. So go ahead and do the reflection first. Then we see that we have a stretch by 5. So this point right here, 1, negative 1 becomes 1, negative 5. It's stretching 5 units. 1, 2, 3, 4, 5. It comes to here. And then this point, negative 1, 1 becomes negative 1, 5. And I have this point right here. And I'm going to do this in a blue dashed line. This is still not my final answer. That is the reflection and the stretch so far. And then finally, I'm going to do my +2, up 2 units. So what happens here is that each one of these 3 points moves up 2 units. So negative 5 moves up to negative 3. So I have 1, negative 3. Actually, I'm going to do that in black because my final answer will be in black. So I have 1, negative 3. The point 0, 0 moves up 2 units to 0, 2. And then the point negative 1, 5 moves up to negative 1, 7. And I'm getting an awful lot of points on here. But I have this point right here, this point right here. I'm going to do them in red, something completely different. This point right here, this point right here, and this point right here. Now, I need to keep in mind that I am dealing with x cubed. That's going to help me draw my graph. If I'm trying to look at all of these other sketches I have here and think about moving them up and down and reflecting and whatever, I'm going to get very confused. But if I know that I have this ordered pair, this ordered pair, and this ordered pair, and this ordered pair is the one that was 0, 0, then I can just draw my curves the way I know that x cubed should look. And I can draw my final graph of g of x. I'm going to have you do one more of these yourself. Let's say that we have y equals, and I keep changing the value here, y, g of x, f of x, that really doesn't matter. These rules work regardless of what you call the function. So let's say we have y equals 2 times the square root of x plus 4. What I want you to do is write the basic function, sketch the basic function, plotting a couple of points, list your transformations, and then I want you to try to graph y yourself, and then check back and see what I've done. Pause the video, do this work, pause the video, do the work, and then turn the video back on after you've tried to graph y, and then compare to what I do. All right, my basic function here is the square root of x. And if I graph the square root of x, this is the one that doesn't have anything over in the negative x's. I have 0, 0. Square root of 1 is 1. And that's what my graph looks like. This is y equals square root of x. And then for my transformations, I'm multiplying by 2. That is a stretch by a factor of 2. And I have my plus 4. That is up 4. So I'm going to take my point 0, 0 stays where it is for my stretch. My point 1, 1 becomes 1, 2. And then I reproduce the same basic shape. And then I go up 4. So this point 0, 0 moves up to 0, 4. And the point 1, 2 moves up 4 units. So it moves up to 1, 6. And this was my point right here. This was the point right here. So then now I recreate my graph, and I have y equals 2 times the square root of x plus 4. When you're doing your homework online in my math lab, I very, very strongly recommend that you do these steps. Write this on paper, showing your work. Then, when you go into the graphing tool, you can select the correct shape, you can do the correct transformations, and it will automatically do it for you in the graphing tool. But to really understand the transformations and understand the shapes, and we are going to use these transformations quite a bit through this semester, I think it's important that you do the work and show your graphs on paper, and then do the work online using the graphing tool.